Welcome back to your very own Expert-Gyan live session. As you know, 9SEM is India's first skill-based digital learning platform that provides job guarantee training and guidance to engineering students and aspirants of core and non-IT industries. As always, we'll be having an esteemed industry expert in this session to answer all your questions. And what better way to commence the commemorations of 75th Independence Day, Azadi Ka Amrit Mahotsav. When India embarked on its Digital India initiative, no one could have predicted the speed at which digital transformation would impact our daily lives. Many of the ambitious projects which were envisioned that have already transformed our day-to-day experiences. Today, we have with us Mr. Harshit Arora, who is a mechanical engineering expert with a keen interest in designing, analysis, and development of new machines and achieving operational excellence in mass machinery and manufacturing. Hello, Mr. Harshit Arora, how are you?
Hi, Sikna. I'm fine. How are you?
I'm great. Thank you for joining us.
It is a pleasure to join here and share my views on mechanical design engineering with you. I'd be delighted to share my experience here.
So let's start with the PPT.
Yeah, sure.
Yeah, is my screen visible?
Yeah.
Yeah.
So let's go ahead with the first slide. Yeah.
Yes.
So I'm here to discuss about the career opportunities in designing for mechanical engineering students. Next slide. So let me first discuss about designing. What is designing? Designing is basically first imagining an idea or a machine or something that you want to design, and then you work on it by sketching it, drafting it, using a suitable choosing a suitable material so that you can improvise your design and meet the needs of the industry. Next slide. So the relevant subjects in the mechanical design engineering that a student should study are mathematics, engineering, mechanics, kinematics. That includes the statics and dynamics parts of engineering, theory of machines, strength of material, engineering, drawing, and manufacturing processes. So these are the basic subjects that an engineering student should study and focus on, so as to have a career in the design field. Next slide. So, how is designing done? First, we decide the purpose and the use of the machine that we want to achieve. Then, we calculate the size and use suggest the raw material which is necessary for designing the machine. Once that's done, a team of engineers sit together and they draft a design by pen and paper, and which includes every engineer, be it from electrical, be it from design, be it from electronics field. They sit together and they discuss about the ideas, and then once everything is done, the mechanical engineer works on softwares like SolidWorks, AutoCAD, and he develops the machine on it. Once the machine is developed, the role of a mechanical engineer is to do the analysis of the software. Analysis is basically studying the structure, the dynamics, and the statics of the machinery, so that any load or stress calculations or any fluid is involved, and all those things are taken into consideration so that the design is meeting the needs of the client, and a machine which is to be used is finalized. Thank you. Next slide, please.
Yeah.
So, what are the advantages in designing? The advantages in designing when it comes to manufacturing are it takes less time, because in designing we can do it on computer, while in previous times everybody used to think of an idea and then do it physically, so as to get to the point that the machine should be manufactured. So if a heavy machinery is involved in that, it will take a lot of time and money. And if this manufacturing is done on computer, it takes less time and all the analysis can be done on the computer. Also, once the machine is manufactured, there might be chances that the machine manufactured in older times that was done by physical methods were not up to the mark or had some defects. So for that, we had to redesign it again, and more time and money was infused in this. But when designing was developed, the machines and every part can be minutely studied, and the time and the money involved can be reduced to minimum. Next slide, please. So the various design software that I use and a design student should be using in order to make their career in designing should be AutoCAD 2D drafting, AutoCAD 3D, that is 360 Fusion, SolidWorks, CATIA, Pro E, and NX. So these are the software that a person should know or should use in order to get know about the design. These softwares can be learned on any platform, be it YouTube or any courses you can do, and you can study it. Next slide, please. Once the design is done, the most important step is the analysis part, because design can be designed by anybody, but it has to be feasible and it has to be manufactured correctly in order to meet the industry standards. So for that, we use different softwares like ANSYS for finite analysis, CFD analysis when fluids like gases and what liquids are involved. We use SolidWorks, Fluent, HyperWorks. When it comes to checking cooling systems in HVAC, etc., we use Flowtherm and IcePack. Also, MATLAB is used in order to check the analysis and the design of the machinery. Also, a student should know Python, C++, and other visual basic coding language, which should be basic, so that because these softwares require a coding language to be learned by the student. Also, Microsoft Excel is a useful tool in this, because these tools are data driven tools. So in order to study and provide data to these softwares, Excel has to be learned. Next slide, please. Design standards. So when it comes to designing, there are a lot of design standards that are involved. So you cannot just design anything which comes to your mind. There has to be a rules and regulations that have to be followed in order to design something. Like when a coupling or a flange is designed, and it is to be designed in inches system, or a gear is has to be designed. So the pitch and the uh, teeth, number of teeth, diameter, and depth of teeth are standardized, and that is the way those are manufactured. So the design standards are ruled by various organizations like the ISO, which is International Standard Organization, ASME, which is American Society of Mechanical Engineers, and European norms are used. Next slide, please. So, as we funnel to the design opportunities that are present for various students, there are various fields and n number of fields where design can be used, and mechanical engineers are being employed. Next slide, please. So, first and the foremost, which is visible to everybody, and it is around us, is the automobile industry. Automobile industry has n number of parts involved, like fasteners, alternators, engines. Then there are small pipings, HVAC system. There is the entire ICGT combustion engine, be it petrol vehicles, diesel vehicles, or EV vehicles, batteries, and n number of things, alloys. Everything has to be designed minutely, so that they do not, because this automobile industry is one of the most important industries, as it has human intervention, like the safety of the human is involved in this. So they have to be designed with very specific details and cautiousness, so that nobody is injured. And in automobile industry, when design is involved, so students design various parts, like they may be side mirrors, or alloys, bumpers. Everything has to be designed, and once it is designed, analysis is done on it, be it collision analysis, be it moving, to check the forces that are applied on the vehicle, and to check the life cycle of the vehicle. Like when it comes to tires, we can check the life cycle using the design softwares and analysis software, so as to know that when is the correct time to change that wheel. So this is the opportunity for students who can study this and get in this field. Next slide, please. So next is the heavy metal parts in industry. So the next is the aerospace. This is the second slide, I guess. Automobile, then heavy parts, I guess. Yes. So this is the industry in which heavy parts, be it spindles, shafts, couplings, because these industries are served by various industries like sugar mill industries, then ceramic industry, tile production industry. Everywhere you see, if you see this picture in the right side, there is a vertical lathe which has a bed of around 100, which has a bed of around 30 feet, which this shaft is produced. So for that, since the raw material which is procured by the company is minimum, so a design engineer is needed to design the exact size of the shaft so that the process is not to be repeated again, and this shaft will be installed in another machinery which might be a part of the sugar mill industry or any other industry. So a design engineer has a very important role when it comes to heavy parts manufacturing. On the left side is the gear gearbox. This is a heavy gearbox which has a motor of around 30 rpm, 30 horsepower, which is installed in various machineries. So this also has to be designed in a specific way so that the torque which is given by this gearbox is used by the machinery and which is correct, and also the gears and the oil and everything has to be checked. So design engineer here has their role as to which gear has to be designed in the correct form, be it the teeth, number of teeth, diameter of the gear. Everything has to be taken into account by the engineer so that the correct torque is given by the gearbox. Next slide, please. Next is the aerospace industry. So aerospace industry is nowadays developing and everybody is inclined towards it because everybody has a enthusiasm towards space. So when it comes to aerospace industry, very minute and small parts are used, and since this carries a lot of people in it, so the safety is the most important part. So for that, design engineers play a role in a way that when any part is designed, it should be designed with utmost cautiousness. And for that, exact knowledge is needed by the engineer so that they can design a specific part and which is suitable for this machinery. Now come, I have shown here the analysis of the aeroplane to check the drag, the thrust, and everything. Like every time we don't have to manufacture a entire aeroplane, we can just change. Supposedly, the wingspan of the airplane here is 10 meters, so we can change it to plus minus 5 meters and check what is the drag or what is the forces that are implied on this. And for that, we don't have to manufacture an entire aeroplane. So design plays an important role here as the cost of the industry, cost of the machinery, and the cost of the company is reduced. Next slide, please. Now comes the plastic industry. In plastic industry, be it injection molding, now the plastic industry has switched to 3D printing, but there are a lot of industries, be it toy industry, like the bottles, the pet bottles that you see, everywhere these dyes are used. So these dyes are manufactured and designed by design engineers, where they design these dyes in a way such that the extrusion by the injection molding machine is done in a proper way, and design has to be peculiar, and also the materials used in the molding machine and the die should be specific to the needs of the machine, because if we choose a material which is not good enough for the machine, then there might be chances that the machine might burst or something might happen, which will lead to the safety of the operator. So it is very much important for the design engineer to choose the right amount, correct material. For that, the certain subjects that I discussed before have to be studied in depth by the engineer, so that the correct material can be used. Next slide, please. So robots manufacturing industry is booming currently, as everybody is moving towards an industry where humans and robots can correlate and work dependently on each other, so that in environments where the safety of the worker is harmed, then robots can be used, and the they can help the industry. And also, when it comes to increasing the production, since robots can work for 24 hours and infinitely, but the workers cannot, so these robots are replacing humans. And when it comes to precise parts, these robots are very helpful. So the role of design engineer here is to study the requirements of the industry. Supposingly an automobile industry needs a robot, so they need to study the and understand what kind of motion is to be needed by the robot, and then the design engineer studies these motions. First they create this robot design using motors and everything, and then on the software they dedicate a specific motion to these robots, which is studied. And once this motion is finalized, then the manufacturing of this robot is done. So robot manufacturing is growing these days very much. Next slide, please. So when it comes to medical industry, since prosthetics arms are a lot needed right now, be it legs, hands, or any other organ, the design engineer has to design the arms and legs and everything according to the needs of a user. This is done by measuring the entire environment and the body parts of the person, and then according to its needs they design a part which is to be installed. And with that help, both the person and they can help the person. The second is the use of the design engineer is in manufacturing of various machines, like which are used in the hospitals, like be it small dental machines, be it MRI scans, X-ray machines. And nowadays people are switching to robots for surgery. That is because when surgeries are involved, they are very precise and very peculiar movements are needed, so there might be chances of human error. To avoid that error, now induction of robots in medical industry are used. So as an engineer, design engineer, his role in this industry is to design such surgical instruments in order to cater the people and to cater the operations in the medical industry. For that, a team of biologists, doctors, and engineers sit together and they discuss about the use and the use of the machine, and understand the process it will go under. And then after, the design engineer designs a machine for the surgical needs. Next slide, please. Now, heavy machinery manufacturing industry is another industry where design engineers are used. So, as you can see in the left side, this is a boring machine which is used to do holes in various big machineries. Now, this boring machine itself has to be created by somebody, and this is where the design engineers are used. Someday, let us take an example. The bore here is around 50 meters, and now the boring requirement is now switched to 55 meters. So for that, the boring machine has to be designed in such a way by the design engineer that it can now cut a hole in the part of 55 meters. So for that, he will first take the prototype of this boring machine and then increase the parts accordingly and increase the size of the motors and everything. And that is how he will design a machine which will serve the requirements of the cutting bore in the 55 part meters part. So that is why design engineers are very important, because drafting and designing of this machine will help to cater the other industries. Next slide, please. Now, HVAC manufacturing is another field in which the design engineers are used. So here the design engineers and their role will be to study the outline of the entire structure. Once they study it, they should know the where the pipe should go and where the linings of the plumbing should go, in order to design a specific system, so that the cooling or the heating of the environment is done in a specific way. So for that, engineers are used, and specifically design engineers are used as to discuss and to study the diameters of the plumbing systems, the type of flanges used in it, the type of uh, raw material used in it. And once this material is decided, then they need to study CFD. They need to do CFD analysis and study how is room cooled, how is the room heated, and how is the piping system, from which pipes the cool air should go, from which pipes the hot air should exit. Everything has to be studied, and this is done by design engineers, because we cannot, every time we cannot make an entire system again and again, because that will not be cost effective. So these are studied on the software, and once studying has been done, people are satisfied with the design, then the manufacturing is done. Next slide, please. Now, shed manufacturing industry is another industry. Like for big plants, the sheds are used. So design engineers role is to study the materials that are available in the market, be it beam, be it type of T collar joints, be it rectangular bars, be it anything. So once they design the structure, then they study that the weight of the shed should not exceed much, that after a certain lifespan the shed collapses. So stress and loads analysis is done by design engineers, and various other settings are changed, like the size of the beams and the size of the rectangular pipes are changed, and trusses, type of trusses are changed, in order to check which is the best suited design for the shed. Like, but in previous days, we didn't have any design engineers or anybody. So this was done either by physically installing things or by the idea of the people who had already worked. So this experience was good enough for people, but then in the long run, if something had gone wrong because of the experience of the people, then the safety of the people under the shed would have been tampered. So for that, now design has helped everybody in knowing the structural capabilities of the shed, and where the design engineers are used. Thank you. Oh, next slide, please. So digital twin is an emerging technology. Like in the left, you can see a motor is there. This motor is twinned. That means a parallel motor is created by a design engineer. So now once this motor is created, it in the software everything can be done, the movement, the RPM, the type of the coil used in the motor, everything can be set. And making these changes, what outcome will be there in the motor can be studied. So in that case, we don't have to.
Hello.
Hello, Snigdha.
Yes, yes, you're audible.
Okay, okay. So in order to do that, to study the motor, a digital twin has been created and we can study that. Similarly, when it comes to plant, the entire plant has been created on the software. Like you can see in the right side, the entire plant, the chimney and everything has been created by the design engineer, and a parallel plant has been created some same as the real plant. And now we can move the machinery or the pipings, and we can check and we can make it cost effective. Like supposingly we have some space in the plant and we can shift the machinery there, and then the cost of electrical wiring for that can be reduced, so that increases the profitability of the company, and everybody would be able to do that. But in the previous times this was not possible, as design engineers and the softwares was not present. Now with the inclusion of the different softwares, we can study everything on the computer and then move ahead and make good decisions for the company which can be profitable. Next slide please. When it comes to mining industry, design engineers are used to study the explosion patterns of these mines and the type of explosives that will be used in the mining or the mine, and where the placement of the explosives should be done in order to create a blast which is suitable and does not harm the environment. So designing the entire hill or a mountain and then designing the explosive and then running simulations in these mines are done by the design engineers only. And once this uh, explosion is finalized, then the real explosion takes place, because you cannot do explosions again and again. This will not, this is not feasible. So that is why everything is run on the machines, on the computers, and then a decision is made. Also, since many conveyors are used in the mining industry for moving materials from one place to another or lower place to a higher place, so the role of the design engineer is to study the requirement of the client and then design a machine which is a conveyor specifically, in which the type of motor, the type of flanges, bearings, the type of movement is studied and discussed with the team, and then the conveyor is designed so as to serve the purpose of the mining industry. So a design engineer is very important in mining industry as well. Next slide please. So when it comes to measuring instrument, it is the backbone of every industry, because even if you are creating any component, you will require measuring instruments. So these measuring instruments have to be specific to the needs of the person. And also many gauges are created in order, supposingly 1,000 parts are to be created, so every time a micrometer will not be used to measure that. Instead a gauge is used which helps to measure these parts. So this gauge has to be designed in such a way that it is feasible and easy to use by the operator. So the role of the design engineer comes here, so as to design a measuring instrument which is specific to that industry and help the testing process ease out and streamline it, and also fasten it so that many parts can be tested in one go. Next slide please. So, turbine manufacturing, this is another form of renewable energy which is growing, because as we can see people are shifting towards renewable energy because everybody wants clean energy. So for that turbines are used. So every time a person cannot create such a big turbine and study its parts, and the right material has to be used in these turbines. So for that we use design software so as to study the motion of the turbine. Like we can even uh, use and we can even input the speed of the air which will be hitting the wind turbine, and we can judge how much energy will it produce and how much energy will it give to the entire housing or the nearby area. So this all can be achieved just by designing everything, and for that design engineers are very necessary. Next slide please. So these are some simulations videos which Snigdha, can you play the first one? videos, these you'll have to click on the link, which will open YouTube.
It's actually not working.
It's not working. Okay.
Yeah,
Mm, is there any way we can play these videos?
I don't suppose. I think we'll attach it afterwards.
Okay.
I'll share the
Uh,
link
okay.
at the end
Not
of
a
this.
problem. So these are some simulation videos that I wanted to show, which helped us, which taught us how simulations can be studied and in different ways. You will watch these videos and you can get an idea of it. Next slide, please.
So I'll share this video after the session.
Sure, no problem. Next slide, please. So when it comes to manufacturing and designing such things, it is very much important to get to know the metal forming processes, because the design engineer should know when the design engineer should know which processes should be involved in designing of such parts, so that he does not design any vague object. He should be very specific to the design he has. So for that, he should know all the manufacturing processes that will be needed in order to design the item. Let us take example of a toy. The toy can be designed by prototype. A prototype of a toy can be designed uh, by injection molding, but in the design engineer does not know, supposingly the design engineer does not know about this injection molding. Other He suggests a process like 3D printing of it, for it. So the 3D printing is an expensive project, an expensive process, which will increase the cost of manufacturing, and the toy which is to be produced in 100 rupees will now be produced in 500 rupees, which is very wrong. So design engineers should very much know the all the manufacturing processes in order to suggest the best manufacturing process, because the next thing comes the computer aided engineering after CAD design, computer aided manufacturing. This manufacturing involves the correct choosing of the process which is to be used in this process. Next slide, please. So these are some of the advanced metal forming processes that are used in the industry. The design engineer should know all these processes and should know which is the best suitable for their design. These are metal forming in 3D printing, be it plate bending, be it shearing processes, extrusion processes, or forging processes. Next slide, please. So the industry 4.0 is industry has now shifted to industry 4.0, which is now the machines are capable enough to work on their own, but an operator is used in order to run those machines. These are run by inclusion of the AI and the machine learning in it. Like, there is a robot, so the robot performs a specific task. So for that, the AI and machine learning helps to know about its movement, and these can be inculcated in other robots. And now you can use, like, cloud computing and analytics can be used, and internet of things can be used in order to, like, operate these robots just by your mobile. So for that, the role of the design engineers here is, since they are good with computers, they are good with technology, they are good with coding languages, they are good with simulations. So in order to develop these tools, be it machine learning or inclusion of AI in robots, the role of design engineers with computer engineers will be of very benefit. Next slide, please. Yeah, that is all. So we end here.
So thank you so much, Mr. Harshit Arora. That was very, very informative presentation from your side. Now
Thanks a
comes
lot.
the fun part. Now he'll be answering all your questions and solving all your queries. Let's start with the questions. I would really like to know that what made you choose mechanical engineering and designing as a field of study?
So I was always good with computers, and I wanted to study something that was involved in computers. And also, I was an innovator myself. I always used to make things out of my toys that I had. And there is was this toy that used to come when you were younger, which you would mechanics. Yes. So in that you would use screwdrivers and bolts and everything and create something, be it a car or anything. So that idea, I thought, why not implement it in real life, and that made me choose mechanical engineering.
That's amazing to hear. So, how has life been, or how life is like for and of a mechanical engineer? What is the that motivating factor that makes you wake up every day and go to work?
So the idea that makes me go to work every day is the idea to innovate something to serve a client in order to provide them the best design which is suitable for their needs. So to innovate that, to run my mind, to brainstorm ideas, that innovation, that nag of innovating things keeps me going, and that is the thing.
Like, how is your life like of a mechanical engineer?
It is like a normal person only. I wake up in the morning and then do my office work and then everything.
So, would you please expatiate us and our audiences about your first ever engineering design that you created?
So my first design was my vehicle. That I was a part of the collegiate club, which in which we designed a hybrid vehicle, which is a e-cycle in which used to run by mechanical force and also electric force. Once the mechanical force was used, some force of it was used to charge the vehicle, and then the battery was used to run the vehicle at higher speeds. So an efficient cycle was created in which I designed the chases and everything of it. So that was my first design.
Okay. So we know that you're skilled in various designing softwares like AutoCAD, CATIA, SolidWorks, MATLAB, and ANSYS, which I have to mention is a pretty impressive list here. We have two questions related to that, like the students who are aspiring to have a career in the designing sector, do they need to learn any of these softwares during their engineering programs?
Obviously, every student should know these softwares. There are many softwares that are included in their course only, but other than that, in the course only basics are taught. But a student should always, if he aspires to be a design engineer, he should take out time from his schedule and study these subjects in depth, because these are the only softwares that will help him to grow in his career. Now if it comes to designs, he might not have the measurements of the tools he has or the machines he want to develop. So for that he can take the help of the internet, or he can take the help of people like me, and we can help them out with everything.
So out of these, what is the most important software that the student must learn indeed?
So the basic software a student must learn is the AutoCAD 2D. Once the 2D is perfected by a student, he should move towards 3D software like SolidWorks or NX or CATIA, in which different parts are designed in the 3D. Once 3D modeling is done, then comes the simulation. Simulations, where are since I have discussed before, there are various simulation softwares like ANSYS and etc. Finite Element and SolidWorks also, where analysis of different parts are done. So they should know everything.
Since you are an experienced personality yourself, you must have worked on numerous designing projects. So, what would you say was your most successful one till date?
The most successful one that I have, the project that I made a machinery used for manufacturing uh, cups and mugs, ceramic cups and mugs. So that machinery is used in processing um, uh, these mugs on a very industrial level, like n number of mugs are produced. So for that I did the entire drafting, and which motor has to be selected, which part has to be engineered in which way, which brackets and which couplings are used, which gearbox has to be used. Then also the kind of manufacturing processes that are involved, so as the cost of the production is not increased. Everything has to be taken into account, and that was a successful project that I had in, taken.
Wow, that must have been an
Yes.
amazing project, I must say. What is that top notch skill or skills it takes to do this job that aspiring mechanical engineer interested in design as well that students must possess in order to fulfill their desired goals or reach the optimum levels in this particular field?
The first and the foremost skill that one should have is the knack to learn new things. He should always be accepting to learn new things. College is just the beginning of the learning. Learning goes on with life, because as new softwares are included in the field, as new systems are included, the person has to keep himself up to date in order to match the requirements of the industry. And also the most important skill I feel is the patience, because a person has to sit for long hours in front of the computer and study the designs again and again. He has to make alterations in order to achieve the best design possible, and for that patience is the key. So these are the skills that one should.
Absolutely, I agree that patience is the key to success for them, especially a
Yes,
design student.
exactly.
Although the student learn all these softwares, but they gradually forget once they stop practicing. What are the ways for the student to get hands-on experience in real-time basis to implement their design skills?
So I believe a person or a student should at least, if he wants to pursue his career in design, he should at least take 1 hour from his day and specifically dedicate it to design. Be it be it any designing of any part, like a design of a pencil, a small component is also a design. He should dedicate his 1 hour to that, even though practice is not he's not practicing every day, but still, if he has good brains and he has good computer knowledge, I don't think he will forget things easily, because you know alphabets and numbers, right? Even though you're not practicing it since nursery, still you know it. So if you have the interest and the knack to crack it, you will not forget things.
Absolutely. Their determination and their plucky attitude can make them successful in their fields.
Exactly.
So, what is the career path and opportunity student in designing for mechanical engineering can expect in terms of job opportunities, career growth in context with India and abroad?
So when it comes to career opportunities, people can obviously pursue masters, but I would recommend them going for a experience first, because masters also require experience. So be it any industry, they should go for experience first, and they should not bother about the salary that they are getting. They should be happy about the exposure that they are getting in the industry, because it is not easy to get into mechanical field there are a lot of engineers in this field. So in order to get that, life is very long. So these are just small steps a person should take in order to achieve something big. So initially this exposure is very much important, and not the salary that he is getting. It food is very much needed by a person, but the real hunger that you have is to be a good design engineer, and that should be the goal and the motive of a person. So that is how we should go.
Passion is what is needed and not the money should be the focus, right?
Exactly.
Yes. So, last but not the least, what advice or suggestion would you like to give to those looking to embark on the journey of having a triumphant career in designing and mechanical engineering?
So the advice that I should be giving is to first study your core subjects and make a good percentage, because marks don't matter, but then they showcase what you have learned. Like, i- at least you should know 3 4 subjects from your mechanical, which are used in the design, and then you should learn all the softwares, and this is the advice I would give to them.
Yeah, I agree that marks don't matter, but
Yeah,
you should be knowledgeable about what you've studied.
exactly.
So, to conclude this session, I would like to express gratitude to you for taking out time out of your busy schedule for this session. It was a privilege having you here with us. Thank you, Mr. Harshit Arora.
Thank you very much, Snigdha. It was a pleasure connecting you and having you on board. And it was a really great discussion. Thanks for being patient enough to listen to me for 1 hour, even though it was not your forte. But I really like the session. I would hope that these sessions are held in the future,
Yes,
and uh, more people are engaged in this session, and people get to know about the industry.
yes, definitely. Future sessions will be conducted. So for our audiences, stay tuned. Follow 9STEM to get updates for our future sessions. And thank you so much. It was lovely having you. All the very best for your future endeavors.
You too. All the very best.
Thank you.
Thank you.
So we're going to end the live now. Thank you, everyone, for tuning in and stay tuned for further updates. Thank you so much.
Thank you.